All right, so section 3.5, we're going to take a look at analyzing arguments, but we're going to be using what are called Euler diagrams. It is not Euler, that is Euler. It's a mathematician's name, so we're going to say it the way it would have been said, right? Same as Euler. Euler is responsible for a couple other things that his name's attached to as well that you might have seen before in like a geometry class. It's called the Euler formula. It talks about the vertices, sides, and faces of a polyhedra. So polyhedra just means three-dimensional with like flat sides, like not circular, but so think like a cube. And it tells you the relationship between the vertices, that's the corners, the side pieces, and the edges. And there's always a formula. There's always a 2 that shows up. So if that's ringing a bell, great. If it's not, that's fine. But it sometimes shows up in geometry courses. But Euler is also known for Euler diagrams. And let's take a look at our leading idea. So Euler diagrams help us analyze arguments by visually representing different categories and ideas that overlap. So overlapping ideas should sort of sound something like we've seen before, namely Venn diagrams, and they are going to feel like Venn diagrams. They include or exclude one another. Similarly, faith in God invites us to carefully consider how beliefs, values, and experiences relate, where they align and where they differ. Just as Euler diagrams clarify complex relationships in logic, faith in God encourages thoughtful reflection on spiritual truths and how spiritual truths interact with everyday life and understanding. Let's pray. Dear Heavenly Father, I thank you for an opportunity to be here today. I thank you for an opportunity to take a look at how we can analyze arguments, a skill that's actually very important in our lives, being able to understand arguments and work through them. As we look at 2 different ways of doing that today, I pray that you would help those be clear and help them to be useful. I pray in Jesus' name, amen. So let's actually first define what we mean by a valid versus an invalid argument. So a valid argument, or an argument is valid, let me say it that way. An argument is valid when all premises are true, it forces the conclusion to be true. Okay, so when all the premises are true, it forces the conclusion to be true. In other words, the rule holds. Okay, so the argument is valid if the rule holds, whatever the rule is, right? So my daughter leaves her shoes on the floor, I actually take them. If that happens, then it's a valid argument. Invalid obviously means the opposite of that, means not valid. It's also called a fallacy. That's another word that means invalid. I feel like my light switches are funny, so I wanted to make sure that we had all of it off. And we're going to be looking in this section at something called Euler diagrams. And Euler diagrams are going to sort of draw us back into the Venn diagram picture, but we're using them for something different. Another unique difference to them is they don't have this universal set with a box around them. Okay, so we're going to see circles, and they're going to either overlap or be embedded in one another or disconnected. So let me draw you the 3 different pictures that can happen with an Euler diagram. So with an Euler diagram, one option is that we have a circle inside of another circle. This is one option. And actually, let me draw this a little bit bigger because I need a little bit more space to write. They could look symmetric. There's nothing special about how they're sort of drawn. There's just one inside the other. And the example that we're going to look at for this, or the verbal example that shows up when you see something like this, is a phrase like the following: all dogs are animals. So the circle on the inside represents dogs, and the circle on the outside represents animals. And when we looked at these before, we called them subsets. And it is the same sort of idea, right? There's nothing different about that. So we see dogs inside of a larger circle of animals. Cool? Okay, now that word all is what we've referred to as a universal quantifier, right? Okay, it's key here. That word all tells you that it looks like this. So when you see the word all here, that's the important part. Okay, that didn't show up at all. Let me do a different color. How about, let's try that one. It's still not showing up very well. It's looking a little bit yellow on my screen. Okay, I'll have to play with that on those darker backgrounds. I haven't done that yet. All right, a second option is that we have circles that overlap each other. like this. Okay, now that really looks like the Venn diagrams we spent the most time working with, right? Overlapping. And those follow logic statements that look something like this. Some people are mothers. Here we go. So one circle would be representing one of those categories, which is people. And one circle would be representing the other category, which is mothers. And you might be looking at that and saying, well, that seems a little bit funny, but if you think about mothers in a broad sense, that would be not just people mothers, but like animal mothers and stuff too, right? So critters have babies, so they would be included in these categories. So this overlapping people, right, like I'd be inside of there, okay? Because I'm a people and I'm a mother. And then over here, we have all of our gentlemen for sure, right? And probably all of the ladies in this room. I don't know that any of you have kids yet, but if you do, you would be in the middle with me, but otherwise you're over here in the people category. And then mothers is all of your, that are outside the people category would be all of, that are outside of it, right, that don't overlap would be all of your animals and things like that, okay? The key idea here, again, is that we have the word some, okay? So this word some right here is what's telling us that the drawing is going to look like this. And then our last drawing, our last way of drawing these two circles, instead, is that they actually just don't overlap at all. So they're disconnected. Okay, mine almost look like they touch. They're not really supposed to look like that. I'm just running out of space. And an example of that would look like this. No hamsters are humans. Whatever you want to do, right? So one circle is hamsters, and one circle is humans, and they do not overlap. And while that's a logically true statement in terms of what I've created, it's not always something that's quite that obvious, but the key that tells you this is the word no. The no here tells you that they are circles that don't overlap. Okay, so in drawing our Venn diagram, we've got, not Venn diagram, excuse me, Euler diagram, we have to decide which category we're in, and there's a keyword that tells us. Make sense? Okay, so let's take a look and we're going to decide. I'm going to show you how we use these to decide if things are valid or invalid, but we first have to decide how we have to draw them. So here's our first example. Our first example is all politicians lie, cheat, and steal. So that's statement number one. Statement number two, and then they write them almost like it's a math problem, right? Statement one, number one, statement number two, and then there's a line, and then it says statement number three, okay? So statement one, all politicians lie, cheat, and steal. Statement two, that man lies, cheats, and steals. So the claim is, therefore, that man is a politician. Okay, that's the structure of this argument, and we're trying to decide if it's valid. So logic like this throws people, even if some of you are looking at this and saying, well, clearly that's stupid, that's false. Probably because you know people who lie, cheat, and steal and are not politicians, so that part of it is sort of leading you to think that. That's not really why this is false, though. This has to be false on its own merit, which means within the category, no prior experience, no knowledge you have of people and so forth, does the valid hold water? I mean, does the argument hold water? Is it valid? And so these are the kinds of things that show up in courtrooms, right? That potentially would lead a juror to make a decision in a way or in a different way, right? Do they understand how logic works? And it's actually really important. So as we're taking a look at this, which type of circle diagram over here am I going to draw? It's the one that's the first one, okay? The first one, at least for my first argument, right? In the first statement here, it says that all politicians lie, cheat, and steal. That sentence right there says all in it. Everybody saw that? I need to draw a circle inside of a circle. So we're going to draw embedded circles to start with. Now, the embedded circles need to be labeled, much like I labeled my dogs and animals on the other one. So what is the inside circle for that first sentence? Politicians. Okay? So what would we label the outside circle? Yeah, so, and you can just shorthand it, lie, cheat, and steal, that's fine. If you want to be a little bit more like precise, it's people who lie, cheat, and steal, right? That's what we're referring to. So I'll kind of put mine in between and I'll abbreviate people. This is people who lie, cheat, and steal. Okay, everybody good? All right, that's just the first sentence. The second sentence is actually what then tells us what we do, or what tells us what we do next. It says that man lies, cheats, and steals. Okay, so we're going to make an X, and the X is going to represent that man. A lot of times they give you a name of somebody. We'll see some examples of that too. But we want to figure out where in the world in this picture, right, inside the inner circle, inside the outer circle, outside, or is there more than one location where that man could be and still fit the criteria that the second sentence says? So where could my X be and it fit the statement that man lies, cheats, and steals? Okay, so it could be on the outside part of the circle and it could be on the inside part of the circle. Because everything inside the big circle, which is now split into two different areas, are people who lie, cheat, and steal. Does that make sense? So we don't know where that man falls. So now looking at the argument, so we've got the statement first, the second statement, right? These are the premise, right? These are premised right here. Are we forced to say that this conclusion has to happen? No. We do not know by this diagram that the man's a politician. Could he be? Yes, he could be, because the X is in the middle. Like, that is an option. But we don't know for sure that he is. So we would say that this is an invalid argument. I cannot draw that conclusion based on logic. Now, maybe on some other else reason you knew, and that would work. But based on this logic, this progression of logic, I cannot draw that conclusion. Okay, you're try another one? We're going to have some invalids and some valids so you can see how they work. All right, so we've got the next one, same direction, says some nurses wear blue uniforms. How am I going to draw that statement? Two circles that intersect. Fantastic. So it looks like that. What will the circles be labeled? Okay, so we're going to leave the word some off, but we'll put the word nurses in. Nurses. And again, I'm going to be real clear, but you can write just blue uniforms if you want. These are people in blue uniforms. And you can probably think of other people who wear potentially blue uniforms. Who else might wear blue uniforms? Electricians, police officer, janitors. My daughters wear McDonald's shirts that are blue. That's their McDonald's. My son's McDonald's was red, but my daughters wear blue for McDonald's. So there's lots of people who potentially, and that's our prior experience as well, but this is the structure that's described by the first statement. Make sense? Okay. Second statement is Dee Boyle is a nurse. So we're going to do the same thing we did with the that man statement, but our X now has a name. Her name is Dee Boyle. So it says Dee Boyle is a nurse. So where could I put my X?
Nurse.
Nurse. Like here? Okay. Anywhere else?
On the people who wear blue uniforms.
Over here? Not yet. We don't know that about her. We're trying to figure that out. In the middle. Why can I put the X in the middle? Because those are nurses too, right? Everything in this circle that says nurses includes nurses, both the part that's on the outside and the part that's in the overlap. Now, we don't know where Dee Boyle is, right? But she could be in either of these based on the description that she's been given. So can we for sure conclude that Dee Boyle wears a blue uniform? No. And just for fun fact, do you know nurses that don't wear blue uniforms? Yeah, I do too. My daughter-in-law's a nurse and they don't have a dress code like that. Okay. So this one is again an invalid argument because we cannot for sure conclude that Dee Boyle wears a blue uniform. Could she? Yes. Does she have to? No.
Wait, so what's sorry.
It's okay.
The statement underneath the line.
The statement underneath the line is the conclusion. We're trying to decide if the conclusion is a for sure guaranteed thing. So these two pieces at the front are called our premise. They're the parts that we are given as fact, right? These are the facts of the case. And the part at the bottom is like what the jury, or you, is trying to decide if it really is true, or if it really holds true. Okay, so far we've had two that are invalid. Let's see about the next one. All disc jockeys play music. What are my circles going to look like? Circle inside of a circle. You bet. How did you know that? It says all. Very good. Okay, so the all told us that. So what is my inside circle? Yeah, disc jockeys. We'll abbreviate them as DJs, which will be a little shorter to write, especially because my circle is so small. These are DJs. Well, what is the outside of the circle? Yeah, it's music, specifically people who play music, yeah. Okay. So that's statement number 1. We've taken care of that. Statement number 2 talks about Flash Phelps. So X is Flash Phelps. It says Flash Phelps is a disc jockey. So where will I put the X representing Flash Phelps? In the DJ circle. Can I put him anywhere else?
On the outside.
Can you?
Yeah, because all DJs play music, so he is a person that plays music.
Okay, but where does my diagram show that all DJs are?
I guess they're just in the middle.
Yeah. So my circles, the way that they're designed, tell me where I've got to put things. And the DJ circle is only right here in the middle, right? It's not the outer circle, it's this tight little inner circle. And Flash Phelps is one of those, one of those people. So he has to be inside of here and there's nowhere else he can go. Does that make sense to everyone? Okay. So these are the things that we know to be true, those first 2 statements, and we've drawn them appropriately. The question is then, can we absolutely for sure conclude that Flash Phelps plays music? Yes, we can. How do we know? Because he's in the inner circle means he's guaranteed inside of the outer circle. Everything in the big circle is people who play music. It includes DJs, but it also includes a lot of other people. Probably you and me are included in that, right? I'm not a disc jockey, so I would be in the outer part of the circle. Flash is in the inner part of the circle, but he's still inside of, because he's embedded inside of the outer circle as well. So this is actually a valid argument. Okay. There's one type we haven't done. It says no dogs or cats. So what will these circles look like? 2 next to each other. They do not overlap, and they're not one inside of the other. What are the circles going to be labeled? Yep, dogs and cats. Okay, so this is the first sentence, no dogs or cats. The second statement says Deke is a cat. So we're going to write down X equals Deke. Okay, so where will I put the X? What are my choices? Has to be inside the cat circle. Okay, Deke actually was our very first pet that way, and he was a cat. So Deke's inside the cat circle. So the last statement is what we're trying to evaluate then. Do we know for sure that Deke is not a dog? Yes. How come from the picture? He's not inside in the dog circle, right? He's in the cat circle. It doesn't overlap the dog circle. This is a valid argument. Okay, so we've practiced taking these statements and turning them into diagrams. I want to practice going the other direction now, okay? So instead, we're going to be given a diagram, and we're going to make the corresponding statements that should reflect what this diagram is representing. Okay, so the first thing you should notice is that there's a circle inside the circle. So what keyword are you going to have when we write this out? All. Okay, what's it going to say? All what? Good. So we start with the inner part of the circle. All cat lovers are pet lovers. This is statement number 1, if you will. The second statement has to do with what we're talking about for the X that's representing in our problem. So what is X, that statement, going to say? Yeah, so Jessica Long is a cat lover. How do we know that we should say she's a cat lover instead of saying she's a pet lover? Because she's only in the cat lover circle. What if they had shown us a diagram and they put an X in the middle with cat lovers and they put an X in the outside with pet lovers? What would we say? What's that? Cat lovers what? We wouldn't say cat lovers, actually. We would put it, so like if the diagram said this, don't change your diagram for the minute, but just for the sake of argument. If there would be two X's here, our statement would not say Jessica Long is a cat lover. It would say Jessica Long is a pet lover. That's what it would say. Okay? And this would be if the argument were invalid, right? And then the false conclusion would be what would follow. This one's valid. It does not have an X over there. It just has our X in the middle. So let's go back to the one we're working with. What is the valid conclusion then that can be drawn based on this diagram? She's a pet lover as well. So Jessica Long is a pet lover. Okay, does that make sense?
So,
Yeah, no, go ahead,
so
Stone.
if it's in the middle, they're automatically a part of the whole thing.
Correct.
All right.
Yeah, it's just a subcategory. It's something smaller than the category that's bigger. Exactly. Okay. This one's the messiest one that we're going to have for a couple of reasons. So sorry about that. Any thoughts as to why this might be the messiest as you look at it? There's more circles going on, or potentially more statements anyway. So either more circles or more X's. Right? We don't exactly know, but there's more going on, right? And also, we've got a couple different things with alls. We have a couple things with sums. Right? There's a lot going on here. And the other thing that's inherent in this one, although it doesn't really cause it to be different, but it looks a little different, is they don't specify a specific person. Right? It doesn't say Jessica Long or Dee Boyle or Flash Phelps or that man or Deke. Those are all of my individual considerations before, right? It doesn't have that. So there's a little bit different feel to it for that reason as well. It's really not different on that count, but it does look and feel a little different. So let's actually just read through it first before we start anything. It says, all people who drive contribute to air pollution. All people who contribute to air pollution make life a little worse. Some people who live in a suburb make life a little worse. Therefore, some people who live in a suburb drive. Now, the last statement can be a true statement without the argument being valid. I need you to understand that. Like, I think that we could probably say some people who live in a suburb drive is a true statement for probably every suburb you've ever seen in your life. Okay? But just because something's a true statement does not mean that the argument that's presented is valid. Right? You've probably had plenty of arguments with your parents that were not valid. And maybe they've had some with you that are not valid as well. Right? Where the conclusion is not supported by the premise that you gave before. It still may be a true statement at the end, but it's not a valid argument. Okay, so do not confuse valid with true. Those are not the same things. Okay, so let's start with the first sentence. It says, all people who drive contribute to air pollution. What is that going to look like? A circle inside of a circle. And I've got a blank one over here that I'm going to keep going back and forth between because I don't have enough space on that screen. So I'm going to have a circle inside of a circle. What is my inside circle going to be? People who drive. So I'm just going to write it as drivers. Let's try that again. What would my outer circle be? Yeah, so people who cause air pollution or I'm going to write it as air polluters. I don't know if that's an E or an O. It doesn't really matter. We're just going to spell it wrong maybe. It's okay. Okay, that's sentence number 1. Statement number 2 says, all people who contribute to air pollution make life a little worse. So if we had started with that statement, I want you to describe to me what kind of circles I'd draw. Circle inside of a circle, just like last time, right? Okay. But I already have a circle that represents causing air pollution, don't I? I already have that. So what can I do to this diagram to add to it instead of creating another diagram that's 2 circles inside of circles? Yep. I can put another circle around the circle I've already got. I already have a circle for air polluters, right? So ignore for a moment. Pretend even that this one in here. I'm going to put it back in just a second. But if this circle says air polluters, and then I've got another layer I can write out on here that's people or things who make life a little worse, right, on the outer side category, that's what it would be. Now, there's no reason to delete that circle, so I'm going to put it back, but that's what's going on. Okay, it's just another circle inside of a circle, or a circle around what we had before. So we had air polluters. It said make life a little worse. So I'm going to use, again, a pronoun, so those who make life, I'm just going to abbreviate and say worse. Maybe it's a little worse, but worse anyway. Okay, is that all right? Now I've sort of got a target looking thing going on here, right? We're not going to shoot at it, I promise, okay? No bows and arrows, please. The next sentence, though, statement, says, some people who live in a suburb make life a little worse. Now, generally, when we've heard the word some, we've wanted to draw how? I mean, what have we wanted to do? Some Venn diagrams, some circles that overlap other circles, right? We're going to do it a little differently right now. This is going to mirror more like what we did with D. Boyle and Flash Phelps and Deke and what else did we have? That man, right? It's going to mirror more like that. So over here, what we're going to do is we're going to let X be people who live, outline, live in a suburb. Feel free to change the statement or whatever as well, but these are the people who live in the suburb. So it says some people who live in a suburb make life a little worse. So where could this X be and still be in the category people who make life a little worse? Okay, it could be inside on the outside. I heard somebody say it could be in the driver's area. Anywhere else it could be? It could be in the air polluter circle, right? It could be in any of those locations because all of those locations are inside the big outer circle that says people who make life a little worse, right? Okay, so this is the correct diagram. We've got it drawn right. So the question is then, do we know for sure that some people who live in a suburb drive? Difference of opinions. What do you think? It's not valid. It is valid. Somebody want to argue their point? What do you think, Lauren?
It's valid because some of the people who live in a suburb drive, but not all of them do. And so it shows that it's in the drivers, but there are some who are not as well.
Okay, so this is what Lauren's thinking. So somebody who said, I don't think it's valid, somebody give me your perspective. Stone?
This could be totally wrong, but
It's okay, that's why we're talking about it, right? It's good.
because I thought like maybe because it doesn't like up here in the what was the name?
The premise.
Premise.
Uh-huh.
It doesn't like initially say anything about like who like people driving in a suburb.
Okay.
So I thought like that's why it wouldn't be valid.
Okay. Does anyone want to add to either side of the argument? Okay.
Isn't it that we could put the X in any of those three spots? And so if we don't know for sure where the X is. So
Okay.
the X could be in one of the two other circles, and that would mean that they're not drivers, but we don't know.
Okay. Anybody else want to throw your thoughts in? What do you have?
Say like driving's the only way to make life a little worse.
Okay. Okay, so these are all really good points that we have to think about when we make our decision. The one that's most helpful in terms of our diagram is the one that you presented. Actually, remind me your name? Emma. Okay, that Emma presented. We made decisions on where to put our X's, right? And we wanted to put it in all possible locations. So is it possible that we could put it in the middle and it still fit the criteria we had before? It is. But did we have to in the sense that we're guaranteed? And the answer is no. So this argument is actually invalid. And that right there is the best reason, I think, for not drawing these as like the some people as a circle. Because it would give the illusion even more strongly that somehow that category overlaps. And we simply don't know that to be a fact. We're putting our X in all possible locations because we don't know. So we can't make the claim at the end that we for sure then do know that the X should have gone in the middle. Jeremiah?
So whenever X is in the middle, basically you have to put X in each circle.
If X goes in the middle, you don't have to put X in every circle. We saw that in our Flash Phelps diagram. We put X in the middle, and that was the only location for X. But what we also saw in that argument was that by Flash Phelps being in the middle, he was guaranteed to be in the outer area. Yeah.
I'm sorry, I'm still a little confused.
Okay.
We don't know for sure if the X is supposed to be there. Is that what it is?
Right.
And that's
These-
why it's invalid?
All of these locations are possibilities,
Okay, so we don't know for sure.
but we don't know for sure. But they fit with all the descriptions that we had before,
Okay.
right? It's like circumstantial evidence, like in a courtroom. We don't for sure know where those people were. All we know is that they were making life a little bit worse. Were they doing it by driving or were they doing it by something else? We don't really know. Is it possible? Yeah, so maybe it still makes them a suspect, but it doesn't necessarily make them guilty.
So if we knew for sure, we would only put the X where we knew. We wouldn't put all.
Correct.
We wouldn't put all.
Right. Like if the last statement, instead of saying some people who live in a suburb make life a little worse, said some people who live in a suburb drive, then the only place we could have put it is in the middle with the X, and we would have guaranteed no that it was in that spot.
That would have been valid.
Well, it would have changed our last statement as well, right? It wouldn't say drive anymore. We would have some other conclusion that we were even trying to draw.
All right, thank you.
Yes. Still have a question, Caden? No? Okay, they're going to take a little bit of practice. These are very visual, so I happen to be a very visual learner. Maybe you are and maybe you are not. But this is one way of looking at arguments. You ready to look at way number 2? Okay, we're going to stop this video.